In this video, we are going to see about the chemical properties of alkenes. Now, alkenes, there is a double bond or a pi electron present in alkenes. So, we know that the type of organic reaction that alkenes give is addition reaction. The double bond breaks and the attacking reagent can attach to the double bonded carbon atom. So, usually electrophilic addition reactions are given by alkenes. So, let us see examples for the addition reactions of alkenes. The first example is, so first we are going to discuss about the addition reactions. First chemical property is addition reactions of alkenes. Now, under addition reactions, first let's see the addition of dihydrogen. This we have already discussed under preparation of alkanes. That is, the dihydrogen will add to alkene in presence of finely divided catalysts like platinum, palladium or nickel, and alkane is obtained as the product. So, let us write one example for this. The example is ethene, CH2 double bond CH2 plus hydrogen in presence of catalyst nickel. The double bond breaks and hydrogen adds to double bonded carbon. So, we get CH3 single bond CH3, that is ethane, as the product. Now, the next example for addition reaction is addition of halogens. Now, we know that halogens will add to alkene. When halogens adds to alkene, the double bond breaks and the halogen atoms will attach to double bonded carbon atom, and we get vicinal dihalides as the product. Vicinal dihalide. Vicinal dihalide means the halides in which the halogens are attached to adjacent carbon atoms. So, we get vicinal dihalide as the product. Now, fluorine reacts too rapidly with alkene, while iodine does not react with alkene under ordinary conditions. So, we have to study the addition of chlorine and bromine to alkene. So, if chlorine is added, then how can we write the example equation? CH3 CH double bond CH2 plus chlorine Cl2. Here the double bond will break and one chlorine will add to CH, the other will add to the other CH2 double bonded carbon. So, what will be the product? We get the product as CH3 single bond CHCl. The double bond breaks and it becomes single bond CH2 Cl. Now, you can see here the halogens are attached to adjacent carbon atom. So, it is a vicinal dihalide. And what is the name of this compound? The compound is 1,2-dichloropropane. So, this is the product of chlorination of propane, that is 1,2-dichloropropane. Now, next let us see the reaction of bromine with alkene. Now, this is a very important reaction because I told you in the beginning we have a test to distinguish, chemical test to distinguish between two compounds, or write a chemical test to identify the presence of a compound. Now, here what I am going to discuss, that is the reaction of bromine with alkene, is a test for unsaturation. So, next we are going to study test for unsaturation. Unsaturation means double or triple bond. The double or triple bonded compounds are called unsaturated compounds. So, if you are given an organic compound and if you are asked to find out whether it is a saturated or unsaturated compound, we can do this test. And this test is reaction of alkene. Now, here we know that I am going to give the example with alkene because it is an unsaturated compound. Alkene, when treated with bromine water is brown in color. what will happen? Bromine water will get decolorized, which shows the presence of unsaturation. So that is the test for unsaturation, that is reaction with bromine water. Bromine water is brown in color, it gets decolorized if the compound is unsaturated. So unsaturated compound if present, that will decolorize the bromine water. Decolorize means the brown color will become colorless. So we can say that it's an unsaturated compound. And as an example, you can write alkene. I'm going to write ethene, CH2 double bond CH2 plus bromine. What will happen? The double bond breaks, bromine adds to double bonded carbon. We get CH2Br, CH2Br. Double bond becomes single bond. And the name of this compound is 1,2-dibromoethane. Okay, so this is colorless. Now, next I can write example with propane. CH3, CH, double bond CH2 plus Br2. Double bond breaks and bromine adds to double bonded carbon. So CH3 single bond, CH, Br, single bond, CH2, Br. This is 1,2-dibromopropane. So this is a test for unsaturation, that is reaction of the compound with bromine water. If the bromine water gets decolorized, then we say that it's an unsaturated compound. Now, next example for addition reaction is addition of hydrogen halides. See, addition of hydrogen halides. Hydrogen halide is HX. X stands for fluorine, chlorine, bromine or iodine. So this is a very important reaction. Now here also what will happen? The double bond breaks and hydrogen will add to one of the double bonded carbon and halogen adds to the other double bonded carbon. Now here let's see, hydrogen halides add to alkenes and we know the product formed here is haloalkane. Haloalkane is the product. Now, let's see the order of reactivity. Order of reactivity of hydrogen halides towards alkenes. We can write the order as hydrogen iodide greater than HBr, greater than HCl, greater than HF. That means hydrogen iodide will react faster with alkene than HBr, then HCl, then HF. Now what is the reason? Why HI? Hydrogen iodide is highly reactive with alkene. Now the reason is, we know that iodine has a bigger size. So what happens? The HI bond length, if the size is bigger, the bond length increases, bond dissociation enthalpy decreases, means it's very easy to break that HI bond. So hydrogen iodide is highly reactive. Now we are going to see example for the addition of hydrogen halides to alkene. Now when you study the addition of hydrogen halides to alkene, we have to study the addition of hydrogen halides to symmetrical alkene and addition of hydrogen halides to unsymmetrical alkene. So first we are going to discuss the addition of hydrogen halides to symmetrical alkene. Addition of HX to symmetrical alkene. Now, what do you mean by symmetrical alkene? Symmetrical alkene means equal number of carbon atom on either side of the double bond. That's a symmetrical alkene. Now, I'll give example for the addition of hydrogen halide to symmetrical alkene. Example. CH2 double bond CH2. Now this is ethene. It's a symmetrical alkene because equal number of carbon atom on either side of double bond. We have one carbon on this side and one carbon on this side. Plus HBr. I am taking hydrogen bromide. Now what will happen when you react with HBr? The double bond breaks, and since it's a symmetrical alkene, HBr will dissociate as H plus and Br minus. H plus can add to any of the double bonded carbon and Br minus will add to the other carbon atom. So what will be the product? The product will be CH2 will become CH3, single bond CH2 Br. Bromoethane is the product. Now I'll give one more example for symmetrical alkene. CH3CH double bond CH CH3. Now this is butene. Here also we have two carbon on either side of double bond, so it's a symmetrical alkene. Plus HBr. Now here also H plus can add to any of the double bonded carbon, then Br minus will add to the other double bonded carbon atom. Now when you write the product, how will you write it? CH3, CH2, single bond, CH, Br, CH3. Now the name of this compound is 2-bromobutane. That is the product. Okay, so to symmetrical alkene, the H plus and Br minus can be added to any of the carbon of the double bond. Now next we are going to discuss the addition of hydrogen halide to unsymmetrical alkene. So next is addition of HX, hydrogen halide, to unsymmetrical alkene. Now unsymmetrical alkene means we have unequal number of carbon atom on either side of the double bond. So when you write the product of addition of hydrogen halide to unsymmetrical alkene, we have to follow a rule called Markovnikov's rule. So we are going to see what is Markovnikov's rule. Now the rule is this. The rule states that addition of hydrogen halide to unsymmetrical alkenes take place in such a way that the negative part of the addendum, addendum means adding molecule, goes to that carbon of the double bond which carries lesser number of hydrogen atom. So what is Markovnikov's rule? The negative part of the adding molecule. So suppose it is HBr. The negative part is Br minus. This Br minus will go and attack which carbon? Carbon of double bond with less number of hydrogen atoms. So this hydrogen will attack the other double bonded carbon atom. Okay, so this is Markovnikov's rule. We will have an example. The example is propane, CH3CH double bond CH2 plus HBr. We know H will dissociate as H plus and Br minus. Now this is an unsymmetrical alkene because unequal number of carbon atom on either side of the double bond. This side we have two carbon and of this side of the double bond we have only one carbon. Now what is it? Addition takes place according to Markovnikov's rule. What is that rule? The negative part of the addendum will go to that double bonded carbon with less number of hydrogen atom. Now which has less number of hydrogen atom? CH. There is only one hydrogen. Here we have two hydrogens. So the negative part Br minus will add to carbon with less number of hydrogen, and H plus will add to the other double bonded carbon atom. So how can you write the product? The product will be CH3 single bond CHBr, double bond breaks and it becomes single bond CH2. To CH2 H plus is added, we get CH3. So what is the product formed? 2-bromopropane. So this is our major product. Okay, so here whenever we add hydrogen halide to unsymmetrical alkene, we have to follow Markovnikov's rule. So here 2-bromopropane is the main product, major product. Now we have mechanism to study. And the second mechanism coming in organic chemistry is mechanism for Markovnikov's rule. So next we are going to discuss that mechanism. For Markovnikov's rule. Now the question asked is, explain the mechanism for the addition of hydrogen bromide to propane for Markovnikov's rule, or in accordance with Markovnikov's rule, or explain the mechanism of Markovnikov's rule. Now this mechanism is explained in 2 steps. The first step is, now here it is electrophilic addition reaction. So the first step of this mechanism is, hydrogen bromide will provide the electrophile H+, which attacks the double bond to form a primary and secondary carbocation. And we know the secondary carbocation is more stable than primary, and so the secondary carbocation predominates because it's formed at a faster rate. So what is the first step? First step is the addition of electrophile, that is H+ to the double bonded carbon, and we get 2 products, that is both are carbocation. One is a primary carbocation and the other is a secondary carbocation. So let's write the example for step 1. So step 1, the explanation also has to be studied. That is, the electrophile H+ is added to the double bonded carbon atom to give primary and secondary carbocation. The secondary carbocation, being more stable than primary, will predominate as it is formed at a faster rate. Now I am going to write that equation: CH3CH double bond CH2 plus HBr. So from this, the electrophile is H+, it will add to both the carbon atoms and will get the product as CH3. From this, Br minus will not react now, only H+ will react. So what will be the product? H+. Only this H+ reacts. So the product is CH3, CH2, CH2 with a positive charge plus. Now this H+ will attack this carbon, so it will be CH3, CH plus CH3. Now you know carbon carrying positive charge is carbocation, and the first one is a primary carbocation and second one is a secondary carbocation. Okay, now which is more stable? The secondary carbocation formed is more stable, and secondary carbocation will be formed first. Okay, so this is step 1, that is formation of carbocation by the attack of electrophile H+ to double bonded carbon atom, and we have to write secondary carbocation is more stable. Now what is the second step? That is step 2. Step 2, we have the secondary carbocation is attacked by Br minus to form the final product. So step 2, you will show CH3, CH, CH3. This is our secondary carbocation. Attacked by Br minus, we get the final product. The final product is CH3, CH, Br, CH3. That is 2-bromopropane is the product. Okay, so this is the mechanism for Markovnikov's rule. That is, the first step is the attack of electrophile H+ on double bonded carbon to form primary and secondary carbocation, and secondary carbocation being more stable is formed at a faster rate. So the second step is attack of bromide ion on the secondary carbocation to give the final product. Now, next we have something called AntiMarkovnikov's rule. So, we are going to discuss AntiMarkovnikov's rule. AntiMarkovnikov rule. Now, what is AntiMarkovnikov rule? Now, there is another name for this AntiMarkovnikov rule. It's also called peroxide effect or Karash effect. All the three mean the same. Now, what is AntiMarkovnikov rule? In the presence of organic peroxide, so AntiMarkovnikov rule takes place in the presence of organic peroxide. The addition of hydrogen halide to unsymmetrical alkene take place opposite to Markovnikov's rule. So that is AntiMarkovnikov's rule. That is, AntiMarkovnikov's rule takes place in the presence of organic peroxide. What will happen? Addition of hydrogen halide to unsymmetrical alkene take place opposite to Markovnikov's rule. Means, according to Markovnikov's rule, the negative part of the addendum will add to carbon with less number of hydrogen. But in presence of organic peroxide, the negative part of the addendum will add to carbon with more number of hydrogen. Now, example for organic peroxide is benzoyl peroxide. So, the formula is C6H5COO twice, or you can write it as C6H5 COO C6H5. This is benzoyl peroxide. Okay, so usually this organic peroxides are taken for AntiMarkovnikov's rule. Now, let's write example. Example for this. With propane we will write CH3 CH double bond CH2 plus HBr. Now, I am going to write organic peroxide above the arrow. So, whenever you see organic peroxide above the arrow, or you will see benzoyl peroxide formula, then the product is written according to AntiMarkovnikov's rule. So, here we have Br minus added to carbon with more number of hydrogen, and H plus will add to the other carbon. So, what will be the product? CH3 CH2 CH2Br, or what is this compound? This compound is 1-bromo propane. Okay, now I'll write the same equation and with Markovnikov's rule, propane. Already we wrote, but still HBr. Now here above the arrow nothing is mentioned, means addition takes place according to Markovnikov's rule. So, negative part will add to carbon with less number of hydrogen, and H plus will add to the other carbon. So, what will be the product in this case? It will be CH3 CHBr CH3, and the name of this product is 2-bromo propane. Look at the product, both the products are different. And AntiMarkovnikov's rule proceeds through free radical mechanism, which you don't have to study. Okay, so this is Markovnikov's rule and AntiMarkovnikov's rule. Now, this Markovnikov's rule can be applied not only for the addition of hydrogen halide, we can use it for the addition of acids, addition of water, etc. to alkenes. So, this is Markovnikov's and AntiMarkovnikov's rule. Now, the next example for addition reaction is addition of water. So, D is addition of water. Now I'll write example. Now here, if it's an unsymmetrical alkene, addition takes place according to Markovnikov's rule. If it's a symmetrical alkene, then addition takes place, the positive and negative ion can be added to any of the C double bond C. So I'm going to give example, CH3, C, CH3 double bond CH2 plus H2O. This is also called hydration of alkene. Addition of water is also called hydration of alkene. And the product formed is alcohol. Very important. The mechanism you will learn next year. So here we have H2O. Now H2O, you know, it decomposes as H plus and OH minus. Now this alkene is an unsymmetrical alkene. So addition takes place according to Markovnikov's rule. Therefore OH minus will add to carbon with less number of hydrogen. Here you can see this carbon don't have any hydrogen. So OH minus adds to C and H plus will add to CH2. So what will be the product formed? Product formed will be CH3, C, CH3, then we have OH, single bond, CH2 becomes CH3. This is the product. Now, if you name this alcohol, alcohol is the product. If you name this 1, 2, 3, this is 2-methyl propane 2-ol. That is the alcohol. Okay. Or you can also name this as tertiary butyl alcohol. CH3 tri-C is tertiary butyl group. So, tertiary butyl alcohol. Now, this is the hydration of alkene to alcohol. Okay, and we have already discussed under preparation that dehydration of alcohol. Dehydration of alcohol means removal of H2O from alcohol. We get alkene as the product. So this is something very important to be noted. Hydration of alkene gives alcohol as the product. Dehydration of alcohol gives alkene as the product. So this is our addition of water to alkene. Now the last addition reaction is addition of sulfuric acid. Addition of sulfuric acid. Now we know that sulfuric acid means it decomposes to give which all ions? H2SO4 decomposes to give H plus plus HSO4 minus ion. So we have bisulfate ion as negative ion and H plus as positive ion. Now here also addition takes place according to Markovnikov's rule if it is an unsymmetrical alkene. Now let's see what is the product formed. Cold concentrated sulfuric acid adds to alkene to form alkyl hydrogen sulfate. Alkyl hydrogen sulfate. Okay, so this is the product form. Let's write example for the addition of sulfuric acid. Example, CH2 double bond CH2, ethene, symmetrical alkene plus H2SO4 gives. Now I told H2SO4 dissociate into H plus and HSO4 minus. Now HSO4 minus, it's a symmetrical alkene, so H plus can add to any of the double bonded carbon atom, then HSO4 minus will add to the other carbon atom. Now the product will be CH3 single bond CH2 HSO4. Now alkyl hydrogen sulfate is the product. Here we have two carbons, so it is ethyl, alkyl group is ethyl hydrogen sulfate. Now we have one more example here, that is CH3 CH double bond CH2 plus H2SO4. Now this is an unsymmetrical alkene and we know H2SO4 decomposes as H plus plus HSO4 minus. So the negatively charged, it's an unsymmetrical alkene, so addition takes place according to Markovnikov's rule. So HSO4 minus will add to carbon with less number of hydrogen, H plus to the other double bonded carbon. So let's write the product. The product is CH3, CH, write this HSO4 minus in bracket, single bond CH3. Now the name of this product is propyl. 3 carbon is propane, so alkyl group is propyl hydrogen sulfate. So these are the different addition reactions given by alkenes, and very important is our Markovnikov's and AntiMarkovnikov's rule. So with this we complete the addition reactions of alkenes. Thank you.